Thank you, thank you. So Steven is very nice to me. I don't know why, but he is. Right, so today it's going to be quite technical because I'm going to tell you a story of my life. And I'm not actually kidding. Actually, I do kidding. It doesn't matter, you'll find out. So I really care about performance, and I care specifically about web fonts performance because I really wait a lot. I spend a lot of time waiting on the web. Sometimes I feel like I spend more time waiting than actually working. And it's really, really bad. Because the reason for that is that I'm traveling so much and I end up being on a really bad connection all the time. And I'm not talking about bad 3G connection, I'm talking about bad edge connection, right? Actually, it's a good exercise just to go outside in the woods every once in a while, like every month or so, just for one day, and try to access any of the website that you've built or you are building or that you're accessing every single day. It's so painful. And one of the main reasons for that is actually web fonts performance. Okay, I did that yesterday. It's not that important. So I kind of like stories and I kind of like maps. I've been a big fan of maps for a while. And it kind of keeps me wondering. I kind of kept collecting them for a really long time. And sometimes they have this nice visual texture, right? Sometimes there's nice colors that you can actually just immediately see what belongs to where and stuff like that. They also have lines. Sometimes they have landscapes and things like that. Sometimes you have grids, right? And dots. You like grids, we know that. You also have lines. Sometimes it can be as flat and simple as that, right? You don't really need colors. But they're really expressive. I like how expressive they are, right? I'm just wondering what would have happened if every single time we looked at a map, we would need to wait for text to start rendering. That would be kind of useless, right? Because you can't use a map without text, right? And I kind of like this quote a lot. The virtue of the maps is that they show what can be done with limited space. They foresee that everything can happen therein, right? I kind of like that because when I think about that, I think about constraints, and I really like constraints because they kind of force me to really think slowly about what I'm designing, what I'm building. I think it's really important. However, I don't like being slow, and this is literally a story of my lifetime. This looks more like this, where you have a loading indicator, right? And I keep waiting all the time, right? And you might be thinking, well, we have a good connection these days. That's not a big problem. Shouldn't be a big problem anyway. We have 4G probably almost everywhere, and we have a really good coverage probably everywhere. Well, that's not quite true unless you live in South Korea and Sweden, where you have a really good 4G coverage everywhere. Most of the time in Germany, for example, you'll be spending on 3G, although you have 4G. Where is Switzerland? Okay, it's not on the map here, on the chart here. But it probably is somewhere around here as well. So approximately 50-60% of the time, although we're promised 4G, we're getting 3G. And the main reason for this is not because those operators are lazy. It just requires a lot of effort to change infrastructure nationwide. It's kind of a big deal. So we are still there, and even fast 3G is sometimes not fast enough, really. So as Brett Frost said once, many people in the design process simply don't know a lot about performance consequences of their design decisions, right? Because we tend to think a lot about designing first and then kind of thinking about performance. But it helps me a lot to know how many fonts, for example, how many typefaces I can use in a design before I start designing, right? I really like this limit. I really like this constraint, right? The question is, how do we get there? And there are obviously a few ways to kind of quantify how much your web fonts budget is or whatever. We can talk about it a bit later. But it's really, really important to keep these web fonts in mind in the very start of the process, not in the very end of the process when you have to work on performance. Because you might end up with something like this, right? Where you have those charges, roaming charges, which are just ridiculously high. Now, Tim Cadlick did a little experiment, and I followed him as well. So I'm using T-Mobile, and T-Mobile has free plans. Or basically, well, I have one plan, but they kind of differentiate between three groups of countries. Very friendly countries, not so friendly countries, and really not friendly countries, right? So if you happen to be in a friendly country, you're going to spend 53 cents for a megabyte, which is fine. It's even not expensive considering Switzerland, right? But if you end up in a country like this, right, in a really not friendly country, you're going to spend 79 euro cents per 50 kilobyte of data. That's a different story entirely. So, a while back, I went to Moscow. Can you guess where Russia is in this chart? You probably can. So I'll be spending 79 euro cents per 50 kilobyte of data. This is not cool. Because if I wanted to access vogue.co.uk in Moscow using roaming charges, I would need to pay 93 euros and 13 cents just to see the full front page of Vogue in Moscow, right? At this point, this is just ridiculous because for the same amount of money, you can get 16 print editions of Vogue, right? This is just not cool. Okay, I lied. And it's morning, so I'm allowed to lie. Because T-Mobile has a really interesting restriction. Because the connection will be interrupted once you reach 5950. And because, of course, they block rendering all the way till you render everything, because they have JavaScript at the top of the page and web fonts and images and Retina images, which have to load first for whatever reason, I will see pretty much nothing except the navigation for 5950, right? I can almost get the same with about blank, right? I don't have to pay 59.50. This is just nuts. This is just not cool. And as Andy Hume said in one of his talks, there's literally no difference between a website being down and a website being inaccessible due to loading issues or if it's not loading, right? It doesn't matter. It might not even exist, right, at this point. So whenever I think about web fonts and performance, this is the image I have all the time. This is my life. Why? Why does it happen? What is the reason for this? And it's kind of getting even worse. Because actually, when you think about web fonts, we spend a lot of time thinking about images and responsive images and how they're fat and they're kind of putting weight on the websites. Well, it's the same with web fonts. It's not much different. Actually, if you abstract from the data itself, this is kind of a really massive trend. And it's not going to get any better. So what does it lead to? This experience. You come to a website, you see link underlines. Welcome, wonderful link underlines. At some point, fonts start kicking in, right? And then more fonts start kicking in, and then at some point you see advertising and you're done, right? Of course, different browsers have different behavior, but pretty much it's all the same because you have to wait, right? Now, if you think about web fonts in general, so okay, let's talk a little bit about what we can actually do to make it better. But more specifically, what web fonts we have to approach this problem. So the choice of formats depends on browser support. What do you want to support? Now we have WOF, we have DTF, OTF, EOT, SVG fonts, and WOF2, right? Now they might be used in different situations. So WOF has a really decent support. It has the best compression, but it isn't supported by all the Androids and iOS. But WOF is, right? So WOF2 is kind of a new iteration of the WOF format, and it actually really promises much, much better compression. And it's supported by some browsers already as well. Now, all Android and iOS support TTF and OTF. And Internet Explorer, of course, because it's Internet Explorer, needs EOT. I hate EOT so much. It's unbelievable. It's like, whenever I say EOT, it's like hurts. So SVG, however, is really useless, to be honest, at this point, because it doesn't support OpenType features. It's not widely supported, so we can forget about SVG altogether, right? And instead, we can just think about, okay, if we want to provide good support, so WOF and WOF2 with TTF, OTF for Androids, and EOT if we want to support 6 and 8, right? But not SVG. We don't need SVG anymore at this point. Although, however, we need to be careful. The choice of TTF or OTF will probably depend on the size. I mean, they're kind of equivalent in a way, so you can use both, right? Or, well, either of them. So this is okay, so we know what to do. Now, how do we embed these web fonts in a page? Well, we have this bulletproof font face syntax, which exists now for a while. We had this fantastic IE fix, because otherwise Internet Explorer is going to download all the files just because it wants to, although it has, it can't really deal with it anyway. But we do want it to get this weird EOT, and then we want smart browsers that support WOF2, get WOF2. Browsers support WOF, we're going to get WOF. Browsers support OpenType, going to get OpenType. Kind of really easy. And if we actually want to cover only smart browsers, it's even easier because we don't have to care about EOT at all, right? So this is kind of nice and short, and life is beautiful, and everything is just wonderful. And I mean, what's the point of this talk? Well, the problem is it leads to some problems. Because when a font family name, right, is used in CSS, browsers have to match it against font face rules. and I have to look out what fonts are available. And if this font is declared, it has to require and request the file, and then eventually display the content, which is why we have things like that in CSS, right? Where we define this font family for, or refer to this font family, sorry, for a specific, div or paragraph or body element or whatever, right? And then if a browser finds out that it needs this typeface, this font, well, then it's going to grab it from the server. What we decided to do in Smashing is to experiment with different font stacks and just look at what changes. So because we want to deliver content as fast as possible, we're thinking, well, what fonts are available as fast as possible? Obviously, safe fonts. But safe fonts differ depending on platforms. So Microsoft, Android, iOS, they all have different fallback fonts, which don't have to be Arial or Georgia. You can actually have fancy fallback font stacks like this one, where we know that Avenir and Avenir Next are available on iOS. We know that Android has Roboto. Well, they kind of dropped droids now, but you can still access them. They're still available. Microsoft has this really nice typeface, which is very much like something between Verdana and Proxima Nova, in a way. Segoe UI, which is really, really nice, so you can refer to that. And for all the other browsers that really do not understand much and do not have a lot of fonts installed, we can just provide a fallback. But obviously, this is our web font that we want to use. But if it's not available, we're going to jump back to those, right? But then, of course, we need to refer to that file. Now, obviously, we do need to, if the file is available, we can just put it on the server and refer to it like this, right? But most of the time, because of licensing, we can't. So we have to rely on external services, Typekit, FontDeck, Google Fonts, and so on and so forth. So we would embed them like this. And Typekit has a really nice asynchronous loading, which helps a lot, actually. But Google Fonts does not by default, actually. So we have to do some work, right? So this is all fine. This is, I guess, what we all know anyway. But this eventually does lead to problems, because this is going to be the loading process, right? You request your HTML, you construct the DOM, then you find out that you need CSS, so you can get the CSS and you construct the CSS OM, and then you figure out, okay, I need to kind of combine, the browser needs to combine the DOM and the CSS OM into the so-called render tree, and then it figures out, oh, I need a font, and then it's going to request it, and in the meantime, users will see either nothing or the fallback font, right? So if fonts aren't cached yet, they will be requested, downloaded, and applied, deferring rendering, which is why this happens, right? Which is kind of bad. But I actually said that different browsers have different behaviors, right? So some browsers have ridiculously bad behavior. They don't behave at all, right? Safari everywhere is horrible, because Safari has decided to wait, like as long as it needs. So if web fonts need 5 minutes to load, it will just wait 5 minutes and show nothing until web fonts have loaded. And then it will actually show the content. That's not really cool. Internet Explorer uses, obviously we have Foyt and we have Faut. Now Foyt is a flash of invisible text, which means you come to the page, no content is displayed until the font becomes available, so you actually see nothing, and then the content is there, right? Faut is a flash of unstyled text, which means we see the content in the fallback font first, and then we have a swap, right, from the fallback font to the actual web font. Is everybody with me yet so far? Are you sure? Okay, all right, it's just way too early in the morning, right? So Foyt and Faut. Now Foyt is being used by IE, and as far as I understood correctly, it's being used by Edge as well, but I couldn't verify it yet because I couldn't install Edge, of course, on the Mac. So just for you to keep in mind, but Internet Explorer uses Faut, which means flash of unstyled text. You see fallback font first, one of those that we had defined, and then eventually when web font is available, you have a switch. The other browsers, Chrome, Firefox, Safari, Opera, and pretty much everything else, they use Foyt, which means nothing is displayed for a while until web fonts is downloaded, well, requested, downloaded, and rendered. But they do have a timeout, which is good. So if nothing happens within 3 seconds, they will kind of switch back to fallback font, right? Which is kind of a good idea. So you don't have to wait internally for the web font to be downloading. Although you do have to wait internally for Safari, if you like. But I think they are going to change it in Safari 9. So in the worst case, you might end up with this kind of experience, right? When you come to the page, link underlines, oh, because it's not a link underline, it's HR, that's okay. But then fallback, after 3 seconds, it was a timeout, and then you wait. You wait, you wait. And then you see that the fonts start kicking in. And I think at this point it's finished, right? But you might have seen a little problem here. So for example, we have a bold here, right? But by default in the fallback font, it wasn't bold, it was fake bold. And you might end up running into these problems with the 4 bold or 4 italic, which are kind of generated by the browser that tries to mimic the experience of being italic or being bold, which doesn't really work well. And we'll talk about that as well. So there are really many little details that can be really, really annoying. So what happens in the worst case? In the worst case, if we request fonts directly, users might be getting a void first, so nothing first, then you have a timeout 3 seconds, and then they might end up with a fault, right? And if they're on Safari, they will wait eternally. So the solution is very easy, actually, and I don't know why we don't talk about it that much, because it's really, really simple. We should really prioritize content over presentation and just deliver fallback as fast as we can without timeouts. Just push it to the user as fast as we can. And then when web fonts are available, we can decide, do we want to have the switch now when the user is on the page, which is a bit irritating at times? Or do we just want to do nothing and then just put it in the cache and on the next visit, display web fonts right away, right? These are just 2 options, and that's pretty much it. So we display content right away and swap fonts later. And on the first visit, users come to the page, they see the content right away, they don't have to wait at all, right? Then we load web fonts asynchronously during rendering, right? Then we cache web fonts properly, and there are different ways of doing that. Some people put these web fonts in local storage, other people actually use, obviously, HTTP. It depends. We'll talk about that too. And then we'll either apply web fonts right away or later. And on the next visit, we apply web fonts only if they are cached. And if they're not, we're going through the same loop again, right? And this is very simple, like really simple, because it really solves this whole technical issue. Now, the best example of how it was implemented and how it actually didn't bring any results was the work that The Guardian did. And they did an amazing work over the last 2 years, kind of moving from non-responsive experience to responsive experience. And they actually wanted to focus just on mobile experience at first. But then it was really important to tackle dropping print circulation. It was kind of a big deal. They were losing readers. And they wanted to replace the slow, rigid mobile and desktop sites by focusing on mobile experience and long-term creating this nice, fancy, shiny, responsive architecture that we all want to have anyway, right? It's pretty much in every single project like that, right? Where you end up with a really bad code base, really old, outdated site, and you want to bring it to a shiny new foundation. And the ultimate goal was one code base, one responsive site that just works everywhere, right? And the solution for that was, probably that many of you are doing anyway. Mobile first, redesign with a strong focus on progressive enhancement. Now, how many of you strongly believe that progressive enhancement is the best thing in the web? Who doesn't believe that? You're wrong. Because it actually is. It's one of the things that really help us build reliable, resilient experiences. And it's really, really, really cool, really powerful. And they also actually had this stealth redesign, which could be useful for your projects pretty much all the time. When you actually look at your mobile experience first, you fork it, you make it shiny and beautiful, you improve accessibility, you improve navigation, you improve performance, you improve everything, right? And you use it as a foundation, right? And then you start growing from mobile to tablet, and then to desktop, and then to TV, and so on and so forth, right? And at some point, if, at every step along the way, you can actually check how much time do I need to do this? Do I have enough resources to do it? Enough people, training? Do I need to do something special to make it really work in the company, within the company? And then you can actually do it like this, and in the end, you can replace the old existing site with a new, shiny, responsive site. So this is a very nice strategy for responsive redesigns. But I'm kind of moving away from what I wanted, because it's redesign, responsive redesign. Right, web fonts. Right, so this is architecture, and it's really, really simple. You have your database, content database, and you have your CMS tools that authors are using, and editorial tools that editors are using, and then you use Write API to submit content, and then it's being read out and goes to the iPhone app, Android app, Windows Phone app, responsive site eventually, and the iPad app, and so on and so forth. So very simple architecture. But what's important at this point is that they brought in this definition of content priority lists, which I think is really, really critical for many of the projects that you might be working on, with or without web fonts. But it was really important to define core. Now, why is it important? Now, it's important because the way you define your core experience will reflect the way you actually load assets, like web fonts or images or anything else. So it's really, really critical, especially when you think about progressive enhancement, because this is like your core experience. This is the worst that can happen to your users. So for them, core content doesn't rely on JavaScript. So even if users have a problem with JavaScript, not because it turned off, but because it hasn't downloaded the JavaScript library, for example, right? They should still be able to read the news. Only one main feature image is considered to be core experience. Now, obviously, images do not block rendering, so it's not really necessary. But in their case, they really wanted to control how images are loaded, because obviously they had to load advertising as fast as possible, right? Obviously, because you don't have JavaScript, you can't rely on JavaScript. Well, they also don't rely on anything that requires JavaScript, like comments and live scores and ratings. They use this technique called cutting the mustard to separate browsers into two groups: smart browsers and, stupid browsers. Web fonts are not loaded by default, just to prevent all of those weird font things, like fold and so on and so forth. So this is what it looks like in decades. They just separate content into three groups: core content, enhancement, and what they call leftovers. Core content is like the thing, right? This is what readers are coming to the site to read the news. So this is the news. Then enhancement, obviously things that are enhancing the experience, like touch things and enhanced CSS and web fonts at this point, and also all the images which are loaded with JavaScript. And leftovers are all the things that are not really absolutely required, like analytics, advertising, third-party content, stuff like this. And what they do is very simple. They load core content as fast as they can, obviously within this 14 kilobyte Google's thing, like inline, trying to push it to the browser as fast as possible, right? And then they wait until it's finished, because they don't want to disturb this core experience, right? And then they load enhancement, and they wait until this is finished, and then they load leftovers. And they use these two events: DOM content ready, DOM content loaded, and onload, which means if DOM content loaded has fired, it basically means that the page starts rendering, which means users can actually start reading the article. And if load has fired, it means everything else has been done, finished, right? And if DOM content loaded is fired after core content is loaded, they know, okay, users are reading. And so we are going to load enhancement. And once enhancement is finished, we're going to file load, and then we're loading leftovers. A really simple separation of concerns, which brings us to this, right? Content, enhancement, and leftovers. Very simple. And nothing from enhancement blocks anything from content. And of course, nothing from leftovers blocks anything from enhancement either, right? So you might be thinking, well, this is weird and stupid. I mean, you are waiting. I mean, you are just doing nothing here, right? Now, the point why you're kind of waiting is because you want the browser to get as much as it needs so it can start render right away. At this point, once it gets this and this, it doesn't have to wait at all. But if you had some resources being loaded here, downloaded and requested, like JavaScript or whatever, obviously browser would wait. And you don't want it to wait at all, right? And you want it to be, like, you want the core experience to be delivered as fast as possible. So you load JavaScript into your browser, obviously asynchronously, because otherwise browsers will have to wait. Now, there is a reason why we don't put JavaScript at the top of the page or in the middle of the page, right? Why, actually? Why do we put our script tag not at the top or not in the middle of the page, but at the bottom of the page? Yes. And the reason for that, for blocking rendering, is that browsers are actually smart, but they also don't want to create noise on the page. Because if we actually put the scripts at the head or at the middle of the page, what would they do? Well, they will look at the DOM, again, HTML first, they will construct the DOM, then CSS, they will construct CSS OM, they will combine the both into the so-called render tree, but if a JavaScript is somewhere in the middle, this JavaScript might be changing the DOM or CSS OM or render tree, and if they actually started displaying the content right away, it would cause potentially a lot of jumps. And they don't want to create this noise for the user, right? Which is why they just wait, because this JavaScript might, change the appearance of the page. But we can tell the browser that it doesn't have to wait. Just do whatever you feel like today. and download all the things asynchronously because they are not affecting rendering, even if they do, right? So it actually pushes the content right away. Which is why we do want to download assets asynchronously, JavaScript asynchronously. So that while JavaScript is being downloaded, executed, and applied, browsers still can parse the document and show content. And the way we would do it is, well, simple. We can use the sync attributes, defer attributes. We can't use them always, but we can often use them. Do you know the difference between the two? They both load JavaScript asynchronously, but yes, so one of them, so defer is the older one and respects the order. So if you have a jQuery and you have a jQuery plugin, you do want jQuery to be loading first and you want jQuery plugin to be loading afterwards, right? And this order is kind of important to you. In that case, you would be using defer, right? But smarter browsers, and if you don't care about the order, you would use async, right? And you would use both if it really doesn't matter for you. So it should be loading asynchronously anyway. And you don't care about the order, but you do want to provide this asynchronous loading for all the browsers, right? This is why you would use both async and defer, just so you know who gets asynchronous loading as well, okay? And this brings us to this, right? So we don't have to wait for this JavaScript and it doesn't have to go separately. Now, there are different ways of detecting if a browser is smart or not, because eventually we don't want to push too many assets to stupid browsers. We want to push this enhancement only to capable browsers. So we can use server device detection. We could. I mean, I'm just saying we could, right? Which use user agent strings with tools like Device Atlas and Wurfel. However, I'm not a big fan of them just because, just a second, I like checking my user agent string. And because I'm running Chrome, apparently, I'm Mozilla, I'm Apple WebKit, I'm Chrome, and I'm also Safari at the same time. I feel really fancy now. It's unbelievable. I'm pretty much everything, right? So this is like, the user agent strings are really annoying, and they're really, really difficult to read. But most importantly, you need a library to maintain them, because obviously you have lots of devices coming up, and somebody has to maintain it. So all of those libraries kind of have to be integrated in some way, which kind of requires a little bit, well, too much work if you ask me. And they're also not reliable. So that's not good. Maybe we can do better than this. Well, we can use client-side feature detection to split browsers into groups again. HTML4, this is what BBC calls it. HTML4 browsers, the stupid ones, and HTML5 browsers, the smart ones. In order to get that, we do this cutting the mustard thing, as they call it. If you cut the mustard, you're a smart browser. So we're checking if query selector is in document, if local storage is in window, and if add event listener is in window. Now this eliminates obviously A8, right? And these two basically are, typical for smart browsers. And by using these 3 lines of code, which often can replace Modernizer, all of those like YepNope and stuff like that, we can actually separate browsers into 2 groups and load smart things only here and not load anything for here, kind of provide basic experience here. If you think about Flexbox, which we talked about yesterday, you can do that as well, right? When you can actually serve a nice Flexbox experience to capable browsers, and all the other ones would get, I mean, unless you really care about the experience, might be getting a mobile experience, right? So IE8 might be getting a mobile layout, if you like, 1-column layout, potentially, just by using few lines of JavaScript. And if this is too much JavaScript for you, you can also get away with 1 line as well. Because there is this fancy API, Visibility State API, which basically does exactly the same thing, which has this kind of separation, right? Again, you don't need Modernizer anymore at all, because if you do not care about probably care about IE8 and 9, but you can provide them with a mobile experience, right? And then you can provide Opera Mini with a mobile experience and all the Androids as well. But everybody else will be just fine. Now, what does it have to do with web fonts? Now, this has to do with web fonts because this defines how we're loading web fonts. Then this is not easy because we need to be able to differentiate between smart browsers and stupid browsers, so that smart browsers will be getting web fonts and stupid will not be getting web fonts, because for them it will really delay everything. It's really not necessary. So what we do is the following. We need 2 checks, pre-render check and post-render check. First of all, the user comes to the site, we check, is your browser smart? If it's not smart, you are not going to get web fonts ever. If your browser is smart, but doesn't support WoW, you're not going to get web fonts. If your browser is smart, supports WoW, but web fonts are not stored in local storage or in cache yet, you're not going to see web fonts just yet. The only way you're going to see web fonts is when you are smart, you support WoW, and your fonts are already cached, right? So we never see the switch, right? And obviously this check has to happen before the body element comes. Otherwise users will see the switch, right? Because the moment content is there, users have to show it somehow. But it also means that when the user comes to the page, we need to check if local storage is available or cache is, can be cached properly. So when the user comes to the first time, they see the content right away, and then we check, okay, if you are smart and you can cache the fonts, well, if you can't cache the fonts, you're not going to see web fonts anyway. But if you can cache the fonts, we're going to download them asynchronously. We can put web fonts either in CSS file with base64 encoded, or just base64 encoded in JSON, doesn't matter. So we download them asynchronously, put them in the cache or local storage, and on the next visit actually show the fonts right away. So who is still with me at this point? All right, that's good. So that's really not difficult, right? The problem is you might be wondering, why? Why would you actually do this in local storage? What is the point? I mean, there are many different offline caching, storage things. We could also use app cache. We talked about offline experiences yesterday. Well, that's a very interesting story, and this is where the spirits do not agree. Caching is very difficult. So there's a little study by Facebook which was published last year, I think, or actually maybe even this year, and another study which was published by Yahoo 3 years ago, where they actually talk about the persistence of caching. Now, when we actually tried this technique on smashing, we found out that although we actually did everything right, HTTP caching was really weird, especially on mobile devices. And some devices behave really strangely. So BlackBerry, for whatever reason, in our case, would just delete all the cache and all the local storage and everything if it's running out of battery. Why? I don't know. It was really surprising. At the same time, we still saw a lot of switch, especially in like in Twitter app, Facebook app, when you use web views, right? Although this cache should be persistent, right? It is connected to Safari or whatever it is you're using on your device, or it's an Android, it's going to be Chrome, right? So it is connected, but it's not persistent, and there was no real study on this. So these guys, Facebook guys, they actually studied HTTP cache, and I was amazed. Caches don't stay populated for very long. Based on our study, there is a 42% chance that any request will have a cache that is at most 47 hours old on a desktop. So if, in other words, actually it's a long study, in other words, if your user has a cache for more than 72 hours, that's a really, really big deal. It's very unusual, right? It's really unusual because if you think about it, how much can browsers store? Now, on average, every web page is like 1-2 megabyte, right? If you cache every single page and all the assets, which are obviously the biggest, like the images and so on and so forth, you quickly will end up, like even after a few months, you will end up with gigabytes of data. So this cache gets cleared all the time. So you can't really rely on things being in the cache. So it's very unlikely that any website, any user of your site has cache that is longer, older than 72 hours. That's kind of a big deal, like really a big deal. Even on mobile devices, right, which actually have limited amount of space, really limited amount of space. So we can't really rely on HTTP cache as much as we thought we could, which is why we decided to use local storage for this, because nobody uses local storage, and it's really persistent because nobody puts stuff in there. Well, this is true, right? So did it bring something to The Guardian? Well, it was remarkable. The result was quite remarkable. This is actually the first site I know that performs better on mobile, responsive site performs better on mobile than on desktop, right? And they also open sourced everything, so you could go ahead and really check what they did. And this web font stuff was really remarkable. It really brought significant results. Now, we tried to do the same thing. And it was basically the same structure, the same idea, the same approach, the same thing. Core content, enhancement, leftovers. In our case, it's different, obviously. We do have, for example, syntax highlighter, which is not really required to start render the page. So we put it in enhancement, but pretty much everything else is the same, right? We still have the same nice separation of concerns. And this is pretty much all we've done to actually make it faster. We load critical CSS inline, which means we just push as much CSS as browsers need to start render the page in the head of the page. We avoid JavaScript libraries, not because I don't like JavaScript, just because I don't not because I don't hate it, but because I don't particularly like it, in a way. We just didn't need it. In many cases, we could replace jQuery with JavaScript, not a big deal. We store web fonts in local storage. We defer advertising, tracking all non-critical CSS and JavaScript whenever we can. We used to use Response.js to kind of mimic responsive experience for IE8, but now we just replace it with fixed suite layout and conditional comments. That's fine. And we always try to optimize the critical rendering path, right? And with web fonts, you can use local font where you drop your WOF file, or WOF2 file, or TTF file in there. It generates the base64 encoded string and the entire CSS file. And you can then use load CSS from FileMan group to actually load CSS asynchronously, right? And this is pretty much it. So you're going to get, oh, this is 0. Okay. This kind of experience. Okay. Oh, it was too fast. The first experience on the first visit, where web fonts are loaded, but you see the content right away after 0.3 seconds. Then web fonts are loaded as very last in the chain, right? And then you see the switch. You could, of course, avoid the switch altogether. You don't really need it. And if you look very slowly, this is what happens. But 0.3 seconds to start reading the news, it's really good experience, right? And if you look at the water chart, this is what it looks like. Pretty much, the browser can actually pretty much start render at this point after 0.3 seconds, 341 milliseconds. And it actually will. If it has all the data it needs, it will start render. It doesn't have to wait, right? So the page will be available and accessible after 341 milliseconds. And then at the very end, when everything else is done, we're going to load web fonts on the first visit. But again, the switch is going to happen only once because then web fonts are going to be stored in local storage, right? So there is not going to be any switch like almost ever because local storage isn't cleared that often unless you're using BlackBerry for whatever reason, right? And this brought us this, right? Again, not a lot of optimization was going on, but it got really, really fast, like significantly faster. So at this point, even in the worst conditions where there's something going on in the first byte time, we still start render under 1 second, right? But if we have good conditions, really good conditions, we start render under 0.5 seconds, right? So this is pretty nice, right? So, all right, this is all cool and nice, but is it really helpful in many scenarios? Can you always use it? Just a second. Okay, I have to show this because I'm very proud of it. Smash Mac is the only site I can read on an edge connection when commuting in Sao Paulo every day. Makes me think why other sites aren't optimizing for slow connections too. Now, the reason is we didn't really optimize for slow connections at all. We just optimized for performance, right? But it's kind of nice to see this as a side effect anyway. Now, you might be wondering, okay, this is wonderful, this is beautiful. We can probably use it everywhere. And I see what you're saying, Basidis. Note you're saying, can we use it in email, right? Can we use it in responsive email? Can we load web fonts asynchronously in responsive email? And the answer is kind of. Well, the support for font face, by the way, in email is remarkable. It's really, really good. So, I mean, it's really, really good. So you can go ahead and use it. The problem is, however, that you can't really load web fonts asynchronously properly unless you don't care about most email clients, which you probably do, right? The only way to actually to be sure that it's being loaded is to use a link or import. But you can't just plug in base64 encoded WOF file in your email. Don't do that. That's not going to end well for anybody. All right, but this is like a hack, actually, right? So what do? Well, we look into the fonts. If we can't store them, WOF or WOF2 or whatever, we just turn them in base64 encoded string, then we load them asynchronously and put them in local storage. The first visit users come to the site, they see content first. We load scripts asynchronously, we put them in the storage, and the next visit we check if it's already in the cache. If it's in the cache, we're loading them directly. If not, we're just doing the same thing again. Right? Kind of makes sense, right? That is really hacky. So the good news is it's being standardized, and the experience that browsers have is going to be standardized as well. And it's being done with CSS font loading API, which uses promises. And it's really, really nice. It's kind of what I explained, what we're trying to do. We want to have a consistent browser experience. We want them to be loading content as fast as you can, and then exchanging the fonts either right away or on the next visit. It's really not such a big deal. It's really not that difficult. But we wanted to, to have a nice, consistent interface for this. So potentially we will be able to use JavaScript soon. Here we're defining a new font face element object, where we say here is our typeface, here are the fonts we need, and here are the weights we need. Potentially with Unicode range if we want, and so on and so forth, right? And what do we want to do? Well, we want to make sure that this font is downloaded. So if it's downloaded, please give the HTML element a new class called lnreg loaded, or if it's failed to load, give it lnreg failed. It's very much like web font load if you're familiar with it, right? Just really natively implemented in browsers. And then we can just refer to it in CSS as we always do. And then what we could also do is to use this new property called font rendering, which allows us to really define how we want the experience to users to be. Maybe we want void, maybe we want fault, maybe we want to change the timeout from 3 seconds to 1 second, or maybe we don't want to wait at all. So here we're saying, well, wait almost infinitely. Wait a second. Flash of unstyled text. So here at this point we say, well, please, yeah, right. So at this point we're just mimicking the fault. So we say flash of invisible text. So don't show anything until we actually have the fonts. And here we're saying the other way around, right? Show content right away, which is what we want, and then wait at most 3 seconds, and after this 3 seconds, swap no matter what, right? Show either the fallback if the font is not available, or just swap to the actual web font, right? So this font rendering property gives us really granular control about how we're going to load this stuff. Well, the browser support is not that good yet, but we're getting there, and the best part is that there is a polyfill for this by Bremstein. So you can go ahead and apply it and use it right away. It's really, really small, right? And the way it works is really interesting, actually, because if you have, obviously, if you have content that has to be displayed in a specific web font, then browsers need to request it. So what you can do then is you have this font face observer, and it basically says, well, please monitor this font for me. I want it to load. I know I need it, right? So it kind of generates a little HTML element with a pseudo element with this font family being used. So it kind of kicks off the loading of the font. Browser actually has to download it before even it has constructed DOM and CSS on, which is pretty nice. So you can use it actually for many different scenarios. And Filament Group actually published another article a while back because they actually do a lot of tracking on what's going on with web fonts performance. And they use font face attribute, font face polyfill, together with a base64 encoded string. And now they actually moved to just linking into it via link ref, right? So it's really interesting. Please do read it. It's really, really cool. I still believe in local storage, though, because of caching. Because like HTTP caching is really a big mess, so we can't rely on this. But I have good news, because I just read about it yesterday. So wouldn't it be nice if we could tell the browser, very much like we do with responsive images, that we need web fonts? So please download them as fast as you can, and don't even think about, and of course start rendering as fast as you can, and don't even have CSS property for it. Well, we can use prefetch in HTML5 to tell the browser, give the browser a hint that it could actually, that we are going to need this file. So please do download this font whenever you can, asynchronously. And obviously, if you're using HTTP2, or if you're using Speedy, this will happen really, really asynchronously, like at the same time, simultaneously, because you can have a number of parallel connections. Anybody still with me? Everybody's still with me at this point, I hope. So it's really nice, and you might be wondering, what the hell is that? Is it actually widely supported? Do browsers understand that? And the answer is yes. Of course, obviously, you know who doesn't support anything, so that's not a big deal. But everybody else is really on board, right? So we can use this property. But of course, it's very much like responsive images, where we tell the browser, we need this file, please download it as fast as you can. But if a user has a bad connection, the browser might decide to just drop it altogether. So it won't even bother downloading the font, and will display fallback font right away. very much like they do with responsive images, where you can define lots of different images. I don't have time anymore, that's okay. Where, where with responsive images, you define a set of images, but it's up to browser to decide what images to pick, right? Unless we're using the picture element. So it's kind of the same thing. If a browser is smart and knows, well, the user is a really bad connection, it's not going to request the file at all. So it's kind of a good thing. So what do we do with those damn web fonts altogether, just to fix it? Well, we can treat web fonts as progressive enhancement. We can use subsetting, and actually Typekit has introduced dynamic subsetting a few weeks ago, I think, which is really interesting and important for Chinese and Japanese scripts because they're huge, like really, really huge. So think about dynamic subsetting as well. But sometimes we just don't need specific characters. Like on Smashing Magazine, we don't need Cyrillic or Arabic, right? So we just remove them from the font. And it can make a big difference too. Consider smart CSS font stacks, like we talked about, like the Microsoft fonts and the Android fonts and the iOS fonts. You need to be really specific to avoid for bold and italic. We don't really have time to show this. It's like one slide. It's not a big deal. It's really just one slide. Because it's really important. It happens all the time as well. So if you want to provide, we want to use Elena, for example, as a typeface, right? Well, you can't just say font family Elena and font weight bold, because this will cause for bold. Because browsers will try to generate this bold out of Elena regular. This is really, really bad. So instead, you just have to be specific. That's very easy. So if you're using font family, if you're using bold for strong, just refer specifically to font family Elena bold and not to Elena, right? And then also use appropriate font weights. So if this web font hasn't downloaded yet, but the user will still see the bold, right? Does it make sense? Otherwise, if you didn't define font weight, they would see regular or italic or whatever, right? It's one slide, so it's a big deal. Right. And, oh, wait. Right, so support WOF2, OTF, TTF, and EOT. Now the problem is you can either actually load your web fonts in your page if you have the access to the files. You can just put them on the server or encode them in base64. Then you can use this local storage technique. If you can't, you have to use either font face observer or web font loader from Typekit. But font face observer is better. It really is. And that's it, right? When embedding web fonts, again, we had that, and defer fonts loading and show fallback fonts first, and it'll be really just fine. It's really just a matter of 10 minutes, seriously. 10 minutes and you'll get it really done. It's really not a big deal. And I won't have to wait so long in the woods, again, on a bench, alone, in the rain.
Hurry it up.
That's all. That's all I've got.
He's got a blatant disregard for anything regarding time. It's like he's trying to get 7 minutes.
I never finish my talks in time, like ever. It's my signature. You should know.
Oh,
that.
It's a signature. All right.
By the way, of course, I have forgot to say. Well, just the credit.
Just
a second.
Give me that thing.
Yeah.
Oh.
Wait, because actually there is a guy. This guy is really cool. Guilherme Kukjian. He did all the illustrations for sections. Those animations are animated GIFs, not GIFs, GIFs. And it's really cool. He's really fast, and he's not really that expensive. Well, he'll be expensive after this session, maybe, but he's really not expensive. So if you need an animation like this, he's really great. And he lives in Nantes, in France. Really cool guy. Yeah.
Are you done now? Are you?
Now I am.
Okay, thank you. The consequence of your actions is that if anyone has a question, they have to come to you.
Oh, that's good.
Because we have to give them time to change rooms.
We have time now.
We have, no, we don't. I'm afraid what will happen if we take a question here. So you have 10 minutes to switch rooms or get coffee or whatever you like.
Or just come
get ready for the next
I have a book to give away. I do have a book to give away. You have to give away now.
All right, give the book away. Hurry.
Yeah, I don't know how to give it away. You have any questions for this?
Just...
I can throw
Let
it?
me think about it. We'll figure it out.
All right.
We'll give his book away sometime today. How are you going to do it? Think about it.
I can just throw it.
I wouldn't throw it.
It's not that heavy.
Please give another hand to Vitaly.